Hey, how's it going, everybody? Welcome to our debut episode of Tech Talk Live on Instagram Live. I'm here with Viega LLC. This is Bo, and I'm going to drag our good buddy trainer Troy in here. Let's see if we can find him. He's probably standing by. Oh, there he is. Look at that. He's ready to go. And he's going to load in right now. Oh, there he is. What's
Hey,
up,
what's
brother? How you
up,
doing,
brother?
man?
Good, how are
It's good to
you?
see you. I'm great, man. It's a beautiful day here in sunny Colorado.
Yeah, it's nice here too. It's hot and humid. It's a pool
Yeah,
day.
that's an East Coast thing.
Oh yeah.
Nice.
Oh man. Well, hey, welcome everyone. This is great. I love it. I got my studio set up just for you, Bo, right in a lockdown garage right here. Hey, working out of the back of my truck still. So
Yep. Yep.
well, hi everyone. I'm Trainer Troy. I'm the manager of technical training and technical support for Viega LLC, covering all of North America. And I operate out of our New Hampshire Seminar Center. And Bo DeAngelo, my co-host, my friend, he is out of Colorado Seminar Center. So we both run all the technical training and stuff for Viega. So yeah, with the face, right? I mean, I don't know. This is
For better or worse.
and I always kind of joke around and stuff like that, but it's like, Bo and I, we come from the field. So we're licensed master plumbers and gas fitters and mechanical contractors, pipe fitters, things like that. And so we came from the field. So I would say that, we were once, if you think about football and baseball, we were once players and now we turned coach. So now we are coaches and we're just training, a ton of people, hundreds of classes a year, thousands of attendees each year. It's fantastic. And now we're coming to you online. And this is great. It's our debut episode on Instagram Live. Everything else was done on Zoom before. So if you missed anything, check it out on YouTube. We get a fantastic team behind us that supports us in marketing. So, but for those of you that aren't aware, we're out of Viega LLC, which covers all of North America. But, we are a global company. So if you're coming from around the globe, if you're tuning in from Germany, UK, I mean, that'd be awesome. So we understand the metric system too, kind of a little bit, so just a little bit, right? But today, what we're going to cover is we're actually going to go over ProPress because that's where we started. We started with ProPress in North America in 1999, and we partnered with our friends Rigid. So I got my tools right behind here. So Viega, Rigid, ProPress started in 1999 in North America. It actually started in 1989 in Germany, so it's been around for a while. And that's why we wanted to bring you ProPress for this first episode on Instagram. And we're going to go beyond the installation manual. What Bo and I want to cover today within this hour is we want to cover some tips and tricks and installation techniques. And of course, I see, everybody joining, saying hi and things like that. Throw some comments and questions in here. And if we can spot them, we'll answer them live right here. So, because a lot of you are already installing our products. You may be installing competitor products, whatever it may be. This goes beyond. This is actually, industry training. So it's all press technology, even though, yes, we're going to be promoting Viega, but Bo and I are familiar with other press technology as well and how they go together. And unfortunately, not all press is created equal. So what Bo and I might say today for our tips, tricks, and installation techniques don't always translate to the other press fittings. So keep that in mind. And that's where you might see some issues, right? So just keep that in mind. If you ever use another press fitting, get trained by that manufacturer because, again, the installation tips and tricks and techniques, they slightly vary from manufacturer to manufacturer. Keep that in mind. So,
Yeah.
but I'm going to kick it over to Bo because he's going to start off today with some tips and tricks and some live demos for you. So what do you got for us today, Bo?
Thanks, Troy. Yeah, we really appreciate everybody jumping in. Just want to give a shout out to my buddy Dave Mahler, who joined us, retired pipe fitter out of 208 here in Colorado. Good dude. We've done a lot of Viega jobs together.
Nice.
He's a Viega champ. Seeing tons of people join in. Really think it's cool. Thanks so much for
Awesome.
tuning in to us. Yeah, it's really cool. This is fun. It's kind of cool to be live. Troy and I are used to being in front of people. It's kind of weird actually not having a bunch of people in front of us, but it's cool. We see you all joining in. So it feels a little bit more real, especially after 4 months of not, having people around. So thanks a lot for that. Yeah, this is beyond the installation manual today. We want to just talk about, being successful with press systems so that you can go out and make a living, make money, I always like to tell our customers when they come to see us, they come for training, that, you know, if I get you home to your kid's soccer game, we win. Done. You know, that's it, man. If I get you home, you know, on time for dinner, if I just get you back because you were able to do something faster and get home, because, you know, we work some long hours in the field. I know you know that, Troy.
Yeah, absolutely, man.
Yeah, so, you know, we win. So that's really what matters. And of course, you know, there's a whole lot of other things to know to be successful with these systems. But ultimately, you know, that speed is what's going to get you back and get you at the dinner table at a reasonable time. And that's really what we're after. But in order to do that, like any other system, you want to understand how to use it and be successful with it. So, and if you caught any of our teasers, Troy talked about insertion depth. We're going to talk a little bit about that today and why that's important and why you want to market and you know, and track, you know, where your insertion is when you're fitting things up. I have a little assembly. I just used it in a teaser. I just reduplicated it today so we can talk about that. We're going to talk about Smart Connect, what that is and why it's important to you. Why does that matter to you? And how does that help with your success? And then something else we want to talk about is that I mentioned it in a teaser video is fitting. And no, I didn't make up that term. It's a term we've been floating around for a while. But it's
I
a
still
sharp
think
little,
it's a made-up term, though. I mean, we floated around, but I tried to Urban Dictionary. It didn't come up. So
yeah, I'm sure there's an urban legend as to who came up with that in Viega, and you know, I'm sure that's going to start a whole thing amongst the sales team. We'll see, but you know, it's a thing that happens, and it actually will happen with any press system. It's not exclusive to Viega. It's just been happening to us longer because, well, we started this party, and we're still partying away. So it's going to happen. And what that is a sharp little edge that pops up after you press the fitting. And if, you know, if you're, you know, you got all these little fins on your piping and you go over and you're like, wow, look at this beautiful piping. And you go run your hands over it. Next thing you know, you got blood all over your piping. And that's not very attractive. So we want to show you how to stop that from happening. And it's a very simple trick. So little things like that we're going to talk about today. Troy's going to talk about some pipe conditions and things you have to know about pipe. And we've got some cool stuff to show you on that. And hopefully you'll get a better understanding of why press works, what you need to know about using it, and how to be successful with it. And if you understand those basic concepts beyond, again, what's in the installation manual, you're going to rock and roll, and you're going to be very successful. And again, you're going to be home in time for dinner. That's all that matters, man, because you know me, my next meal is all I'm thinking about. So I eat like every 2 hours. So
I used to work with a sandwich in my mouth, you know, and I'd just be cranking away and doing stuff, and I'd just be eating. I ate my lunch by probably 7 a.m. because I'd be on the job site by 5 a.m., if not earlier. So I'd eat my packed lunch by 8. Then I'd have to have another lunch before lunch, and then another. I just need that food, man. I need that fuel. So ProPress can allow me to get things done so I can eat.
You know, Troy, what bugs me about you is that you eat constantly and you are like thin and lean and, you know, and I have to work at that. And that really bugs me. I wish you'd stop bringing it up. So
yeah, sorry.
Just
I don't know the last time I walked into a gym.
Yeah, it's killing me. It's killing me, man. So I've set up a couple demos here. I've got a hydrostatic test we're going to do for you, and I'm going to show you. I've actually got a fitting pressed on here that is pressed over some incised tubing. Troy's going to talk about what that means because it's part of a standard, and he'll get into that. And then I've just got some basic piping set up here behind me, and I'm going to actually just rotate the camera. Sorry, joystick error. And so we just got a bunch of unpressed fittings here. So this is unpressed. This stub is unpressed, and hopefully you can see all that, Troy. I can hear you, but I'm not looking at the camera over there. And I've got a T in here, and I've got my insertion depths marked, and this piece is sagging. Now I'm pretty well supported in here, but you know, I've got 3 unpressed connections or 3 unmade connections, so I've got some sag. So if I came along and pressed this without having that mark, guess what? I didn't meet the minimum insertion depth. Now, if I were to have a problem with this in the field and I didn't meet the minimum insertion depth, and just Troy can get into this too, he can explain it from a tech support standpoint, but minimum insertion depth and bottomed out could be 2 different things, okay? Mm-hmm. And so in this case, I just want to, I mean, I can hear it. I'm bottoming out the fitting. You can hear me slapping. I mean, that's good. I know I'm minimally inserted into that fitting, but minimum insertion depth may not mean bottomed out. But my point is that if I didn't meet that minimum insertion depth and I had some issue and I cut that out and I send it back to Viega and say, hey, your fitting didn't perform as expected, I'm going to send it back, or I'm going to get it back, and they're going to say to me, well, you didn't insert it to the minimum insertion depth. And that's a big issue because the sealing element is really critical. That's what's sealing your media, from getting out of the system. So you really need to make sure that the tube is well past the sealing element and you have a good surface to seal on. So if you do that, you're rock solid. I've never had a leak personally. I've been using ProPress since 2007. Okay, ProPress brand since 2007. I've never had a leak on a press fitting. Cover my Viega badge, my Viega tattoo. I don't really have a Viega tattoo, as far as you know.
I don't want to know.
So, thanks, Troy. So, am I blushing? So, I'm telling you, I've never had an issue because I've done it right. I've followed the procedures. I've used good pipe. I've used good tube, rather. And, I've made sure all my connections were pressed, fully inserted, marked everything, never had an issue. So, and you won't either if you do it right. So that's a really important thing. And we're very reliable. We know it. But again, human error always comes into play. Even if we send you a bag of fittings and there's 9 in it, okay, that's a mistake on our part. And we actually track that. And we have a very low failure rate. In fact, it's less than 3 parts per million. We target 14. It's less than 3. And that includes a bag shortage. So that's pretty good. We're very reliable, but you got to follow those procedures. So anyway, I've marked my insertion depth, and again, I've got another unpressed connection over here. But one of the tricks that I was showing in our teaser demo is how to get rid of that fin. And I'm going to bring it up on camera here. I'm going to let it focus in, and you can see that little fin right there.
Of the fitting. Yep.
Yep, that little sharp, that sucker's sharp right there. Now, I actually set that down on the tri-stand and then kind of dented it over, but it's pretty sharp. And some of them can be really, really razor sharp. And all I want to do is get rid of that. I want to knock that off. And I could use a file and, hit that. That's a round file. So I could use a file and knock that off. And it's one way of doing it. It's perfectly fine. But there's a faster way, and it's during the press process. So in the case of this assembly that I've set up here, I'm just going to go ahead and I'm going to actually press my branch first. Now, soldering, we do the branch last, but I'm going to press that first. Okay, and before that jaw is actually stuck on there, it's kind of hard for me to squeeze the jaw here, but all I'm going to do is just twist the tool out of the way, and that breaks the jaw free, and it knocks that little fin off. And again, I'm going to do the same thing over here. Okay, and just rotate the jaw and the fin breaks off. Now, it's still rough, but it's not going to slice you open. You tinners out there, we call those a meat hook. And that's exactly what that is. But real quick, easy step there, just rotate it, and my fin is gone. And that quick, I can knock those off. Now, something else, while you're pressing this assembly, if you want to know another trick, is to control deflection. Now, 3/4 inch tube is not going to move a whole lot. And Troy can speak to that. Mm-hmm. But we get into, say, 1 inch or 1.25 inches, or 1.5 inches, or 2, or then you get up into the larger sizes where we have a grip ring and there's some play between the tube and the fitting. You will have deflection, and we've covered that when we've covered Mega Press, and we've talked about it with ProPress. And what's happening is the tool, when you squeeze the jaw down, when the jaw is closing, okay, the tube wants to get out, okay, wants to leave the jaw. If we could make the jaw do this, we wouldn't have any deflection, but the jaw is more of a scissor action, right? Stay cool, press on, you know me. So that's what we got going on here, right? By the way, I learned that from Troy, I should just say. He does that all the time. You'll see these guys he's got permanent got scissors. Like
I just talk with my hands, man. That's all I do.
You do. I love it. Like, I love it.
Ricky Bobby, I don't know what to do with my hands sometimes,
So one thing we want to do is we want to stop that motion. So if we know that the fitting, whatever fitting type it is, Mega Press, ProPress, doesn't matter, any press fitting is going to want to go out of the jaw, we know where the fitting's trying to move, so we can control that deflection, and we can easily control it by just pulling a little bit on the tool. And I'm using a compact tool, but it works with a standard tool too. It doesn't really matter. So if I were pressing, say, this 45 here, okay, the fitting wants to go this way, I'm just going to pull on it as I make the press. Okay, and then the next side of the fitting, oops, I didn't rotate my tool there. So check this out. I'm going to knock that fin off. We're going to cover repressing a little bit later too. All right. You can repress, and there my fin fell off. We're good to go. Whoops. I squeezed my tool, and
Squeeze now. Trigger finger, right?
Trigger finger, right? So there's a ram release on these tools, and now I can get it open. So in this case, I was pulling against that force, and in this case, I'm just going to let the tool make the press. And it's essentially doing the opposite of what I was doing before, which was controlling that movement, and the fin is gone. So I still have a fitting here unpressed, and you know, I've controlled my deflection. So it's a really simple way to deal with the fitting movement that you're going to see when you make a press connection. Now, we were talking about repressing. You can repress a ProPress fitting, okay? It's not a problem, all right? What we want to make sure you do is you see that the jaw is hex-shaped, right? It's a hexagonal jaw pattern. That's what's providing the mechanical strength when we make the press. It kind of deforms the fitting in the tube. And if you look, I don't know if you can see in there, this piece isn't reamed. Not great lighting, but there's slight deformation back in the hub of the fitting, but it's really, really slight. It's barely anything. But when you repress, we want to make sure that we are lined up. Whoops. We're lined up on the hex, okay? We don't want to be off the hex, because then we're going to change the shape of the fitting. You can see how the jaw's open. So as long as you repress over the hexes, on the flat spots on flat spots, points on points, you can go ahead and repress, no problem whatsoever. So not an issue there. Go ahead and make a repress if you have to. You know, you weren't sure, or maybe you cycled the jaw and you had to take it off because you're like, oops, I didn't really intend for that fitting to be in that position, so you rotate it and you make the press. Maybe you didn't know if you made the press fully. Whatever reason it is, you can repress. It's not going to hurt anything.
So just to elaborate on that, because I see some questions rolling in. So yeah, points to points, flat side, you know, you want flat side to flat side. So this is kind of that action that, you know, Bo was showing there. So this is unpressed. I got a small piece of copper tubing in there, so you can see that action happen. See that hexagonal deformation that it made? That is your mechanical strength, like Bo said. And if I go ahead and I need to repress because, again, rotation or something like that, I don't want to be offset like this, right? So I got flat, you know, high points to flat sides, right? That's not good. It's going to round that fitting out and potentially cause a leak or an issue, right? Now, again, I've had individuals, even myself, accidentally repress it improperly, and 9 times out of 10 it holds anyways. But what you're doing is you're changing that original design of that fitting, that original hexagonal shape that is your mechanical strength. So now your safety factors built in aren't there. So always just make sure to rotate to make sure you have flat sides meeting the flat sides, just like this right here. And then you can go ahead and repress that fitting as many times as you want. Again, the only time you have to repress is if you rotate that fitting more than 5 degrees. So just keep that in mind. The other thing I'd like to bring up, Bo was talking about, you know, mechanical deformation, the mechanical strength. He was talking about insertion depth. So how it be with Danny G, he asked the question, he wants me to settle this debate. He wants to know, well, what is making the seal? Is it the sealing element? Is it the metal to metal? Is the sealing element backup? Does it need to be there? We hear all these stories out in the field. Well, I'm going to settle it right now. You're hearing it from the horse's mouth. The sealing element is needed for this design. So that sealing element, right? So you can see right here, this is a nice little cutaway. That sealing element seals on the surface of that tubing. That is a static seal. So the metal to metal connection is your mechanical strength that's holding that fitting on there. And then your primary sealing source, your airtight, watertight, gas-tight seal, depending on the sealing element that you're using, that is needed. So yes, I could take this sealing element out, press it, and do a cool magic trick and hydrostatically test it with cold water, and you'll see it hold. But that is in a perfect scenario, you know, with a hydrostatic tester, but in a dynamic system, in a system that is going to see water hammer, vibration. It's going to see pressure surges, temperature changes, right? Dual temperature changes. that sealing element is your primary sealing source. So it is needed in there. It's not a backup. It's designed for this type of fitting system. So metal to metal is your mechanical, and your sealing element is your sealing source. So just keep that in mind. So don't take them out. Always make sure it is on the inside. So when I grab a bag out of a fitting, I want to look at it and look on the inside and make sure my sealing elements are in there before I make that press. So, and that's why the insertion depth is so important, because I want to make sure that that's fully seated in, so that sealing element is sealing on the surface of that tubing. Because if I just go ahead and I just barely put that on like that, well, by eye, without marking that insertion depth, by eye, that looks good. I might walk up and press that. I didn't even pass the steel. I'm just on the leading edge. That's it. So that right there is going to cause an issue. So I want to make sure that's in all the way. Mark my seal, right? Mark my insertion depth. So that way, if it bumps or moves or slides off, somebody hits it, or during their pressing action, it can actually pull the other fittings if you dry fit. So you always want to make sure that you mark that insertion depth so you know it's in all the way. I always, got in a good habit of, before I made that press, just make sure it's in all the way, bottom it out. Because Bo mentioned there's a difference between full insertion depth or minimum insertion depth. So when you dry fit and you go ahead and you just push this on all the way and you make that mark, that's your maximum insertion depth. If I go ahead and I use what we call our insertion depth gauge, right? And that just goes on the end of a piece of copper tubing. So see that right there? So I go ahead and I just mark 3/4 of an inch, because that's what the copper tubing that I'm using right now. So I mark that, or I go ahead and read the installation manual, and I read the insertion depth on my tape measure, which is for 3/4 of an inch. I believe those fittings are 7/8 of an inch insertion depth. I'd have to double check, read the manual. But just go ahead, read that insertion depth, mark that insertion depth. But that's your minimum. There's going to be about a 1/8 of an inch difference between maximum, just bottoming it out, dry fitting, versus making your measurements or marks ahead of time. So keep that in mind. There's a little 1/8 inch of a play in between those insertion depths. So stick to one way of marking it, and you'll be good to go. Perfect, Bo. What do you got there, man?
So I just set up a simple hydrostatic test just because I want people to see how Smart Connect works. So there's going to be some camera movement here because I'm going to yank the camera off the tripod and show you the gauge on the hydrostatic test pump. But I just wanted to show you how this works, and I'm going to try and do this two-armed, spread out as wide as I can be, because I don't know if I'm going to be able to reach. But basically what I have here is 2 unpressed connections. I've got water up to this point. You see it dripping out. I've got my fittings marked. I think you guys can see that there. I could zoom in a little bit more. And bear with me 1 second. Whoops, wrong way again. Joystick error, not that way. Let's try this way. Here we go. Okay, there we go. So anyway, yeah, you can see I've got my insertion depth marked there, and then the cap is unpressed. So if I start to pressurize this thing, okay, and I'm just gonna move my pump a little closer here. All right, so you'll see that fluid's dripping out, okay? Basically, Smart Connect is designed, okay, and Smart Connect is third-party proven and tested to ensure that you don't get a false positive, okay? And it's been proven that it will identify an unpressed connection during a step test. And well, what a step test is the step test is the step you're going to take prior to your final test for your inspector, right? Maybe your inspector's coming out, he wants 80 or 100 PSI in your system, whatever it is, okay? That's not where you're going to test to identify unpressed connections. With Smart Connect, you're going to test with either air or water. That's typical in the field. In the case of air, we're going to use 0.5 to 45 PSI. With water, we're going to use 15 to 85 PSI. Okay, if we're going to do a hydrostatic test. As a rule of thumb, Troy and I like to say 30 PSI. If your gauge won't hurt 30 PSI, and most plumbers have a 30 PSI test gauge or test compact tool because it's easier to use one-handed. And I'm actually going to do this backwards, make sure I stay in there. And you can see that it's dripping, and I'm just, whoa, look at that. I actually pressed it, and I'm going to have to cut that off and start over again because I shot it right out because I was putting too much force on the arm. So I'll cut that off and repress it. But I had water all the way up to this point. So that won't hold. I'm probably not near the sealing element. I suppose we could test it right now, but I don't want to because I don't want it to come shooting out into my ceiling. So I'm going to cut that off and redo it. And so while I'm fixing my screw up, Troy.
No worries, brother. I'm here. I can dive into some things.
Explain more about Smart Connect.
Yeah, absolutely. So that Smart Connect that is designed into the fitting itself, and it is going to be you're going to be able to identify that you have a Smart Connect technology, a true Smart Connect technology from Viega by the color dot on the fittings. And that synergy is across the board. That's on our ProPress fittings, our Mega Press fittings, and our PEX Press poly fittings as well. So that color dot indicates that you have Viga's Smart Connect technology. And it is 100% proven that it's going to, identify an unpressed connection during a pneumatic test or a hydrostatic test. And as Bo said, we always use 30. That's just the number I like because even as a hydronic installer, my T&P, my pressure relief valve, that goes off at 30, right, in a residential application. So, I mean, if I can hold 30 PSI in most applications, even if it's an 80 PSI, application for residential, 30 PSI is going to fall in the range because there is a range. You can read our tech data sheets and our PI sheets, and there's a range for MegaPress, there's a range for ProPress, there's a range for air and water. That's 100% proven. That's why I say 30, because I'll remember 30 across the board, and that's good for all Viega press joining methods. So I just, whether it's air or water, bring that gauge up to 30 PSI, let it sit for about 15 minutes. The gauge is holding, you're good to go. If the gauge starts to drop, you missed a press, and you'll be able to go around and find it. If it's water, it's dumping out the fitting as you saw, on Bo's assembly here. If it's air, you're either going to hear it or you can use a soap solution and you'll see those bubbles. Once everything's buttoned up solid, you're good and you're holding a test, you can actually hydrostatically test, do pressure test up to 600 PSI with Viega press fittings, right? So we have safety factors built in. We might say, out of the box, there's a certain pressure range, but you can pressure test up to 600 PSI with MegaPress and ProPress fittings. Don't do it with PEX Press, even though it will hold. We do a burst test in class. We have fun like this. We do the suction test all the time.
Sorry, Troy, forgot the mute.
No worries, bro. No, you're good. You're good. Our PEX tubing actually, burst at 900 to 1100 PSI. So it has a safety factor built in as well, but we follow codes when it comes to testing polymer fittings or plastic pipe and things like that. Operating pressures for ProPress copper up to 300 PSI is your standard operating pressure for ProPress copper. MegaPress is 200 PSI. But if you want to increase those pressures, get a hold of me and my tech support team, and we're able to look at your job. And if you have booster pumps or elevated pressures in a high rise, we can actually approve pressures up to 400 PSI with our press technology. So that's because IATMO tests our Press Connect fittings through a performance standard at that range. So we know we're good. Plus in-house, we have a 5-time safety factor built in. So, reliable, durable, robust, heavier than K copper. It's a strong fitting. Again, not all press is created equal. This really is the best one on the market. So just keep that in mind. All right, Bo, looks like you're buttoned back up there, man.
Yeah, back in business. So this fitting right here is already pressed. I just grabbed a piece that had the elbow with the fin that I showed you earlier. But I've pressed this one so that it's, locked on there. And what I'm going to do is I'm actually going to go ahead and just start the tool a little bit. And now the tool is grabbing. The fitting's not locked on. But now as I put pressure on, I can kind of hold down on my press tool and make sure I'm fully inserted. So, because I don't want that to pop off during my hydrostatic test, but you can see it dripping out. Now, Troy, maybe you could explain, why do I care? Why do I want this thing full of water when I'm doing this test?
So what's great about this is we don't have to drain our systems down. So when I'm doing a test, I'm going around pressure testing, I don't have to, notice the gauge isn't holding, drain it down just to resolder something. I can actually leave the water in there, and I can identify where that, unpressed fitting is, and I can press it live under pressure. And that water doesn't impede, the seal. So I can literally press this under fully pressurized systems or partially pressurized systems. If I'm doing service work and I can't shut a gate valve down, you're trying to do a tie-in, you got to shut down in a hospital or something like that, and you need to get things up and running, things aren't shutting down right, ProPress is the way to go because water can be gushing out, catch it in a 50-gallon trash pail. You're going to get a little wet. Protect your tool a little bit. Maybe put a trash bag over your tool or something if it's a lot of water. If it's a little water like that, something that's partially pressurized, nothing crazy, but, protect that tool a little bit. But, I have guys and photos and videos of guys, in the trenches doing, mains that are burst, and they're, full of water spraying, and they're making press with our ball valves. Press it live, shut it off. Awesome system. So again, you can make that press partially pressurized or fully pressurized. Just be safe.
So bear with me here.
No worries.
So what I'm doing is just coming down here on the hydrostatic test pump. If I can get, so I've got this at 200 PSI. Let's see if I can get right above the gauge so you can see it. I got my lazy hand set at 200 there. Nice. And we're under hydrostatic test. Now, one other thing is when you're doing a hydrostatic test, it is exactly that, hydrostatic. So don't have any air in your system, especially if you have to get up to 600 PSI, which is what I'm going to do right now without trying to drop my phone into the bath of water that is the hydrostatic test pump. But we're just going to go up to, 600. And there she is right there.
Nice.
And my pump is bleeding back. So hang on, let me open this up. Make sure this valve, there we go. And let me lock it down. And I'm a little over 600. Sorry, I'm waving the camera around here. I'm actually at almost 700 PSI, but you know, what's a few hundred PSI between friends? All right, so important thing is that, okay, no leakage. All right, so we do this all the time in training. If you've been to our seminar centers, you've seen us do this, and you know, we do this with Mega Press. We do torture tests. We do rotational tests. There's my other end of the test setup. You know, we're not leaking. So what we're trying to point out here is that, yeah, if you follow the instructions, if you do this right, if you do what you're supposed to do with regard to, you know, having good pipe, making sure your fitting is prepped properly, making sure the sealing element is in there, you're going to be good to go. And there should be no issues. So very reliable system and real easy to use. So hopefully that was good evidence for you.
Absolutely. Bo, can you hear me all right?
I can hear you great, man.
Okay, good. Somebody's
Sounding
Dave
good.
said he didn't have sound for a second. How it be with Danny G asked if Viega makes copper ProPress male or female adapters, or do we only use bronze? So we actually only make our male and female adapters in a high-grade silicon bronze material that has a high, you know, it's a superiority thing. It's not going to wear out. They're not going to dezincify. So the type of material that we use for our adapters, and of course the way in which we manufacture and machine these, that silicon bronze is a nice material. So we don't really like doing copper, you know, threaded adapters because the threads don't come out as perfect as on a bronze fitting. I mean, those are pitched perfect, which I'll be honest with you, because they're perfect, sometimes they don't line up so great with Chinese garbage. So, you know, no offense to anybody out there, but I ran into it. So it's a little personal feeling, you know, where I've had to really, because I use either tape or dope. I don't do both. A lot of people do. That's fine. I don't. But sometimes I find if I'm mating up something with perfect threads, something with not so perfect threads, I do have to tape and dope because they won't seal, because these threads are so, because they're to a T, to the standard. You know, that's the German engineering behind it. So, you know, I will run into that, but high quality silicon bronze, great material. So, you know, I believe in using the bronze adapters versus a copper threaded adapter, where the copper threads can actually wear out, move, tweak on you, chip, you know, so sometimes you don't get a perfect seal either. So again, half a dozen one way or the other, whatever you like, but we like to use bronze for our male female adapters. So just like our ball valves, all silicon bronze ball valves. Got a cutaway one right here, best press valves on the market. So right here, nice cutaway. It's got a bottom loaded blowout proof stem with no packing nuts. So it's, you don't have to service this. I don't have to go around tightening packing nuts for drips and leaks or anything like that. Stainless steel ball, stainless steel stem, you know, again, not going to wear out from water quality. It's not going to dezincify, cause pinhole leaks in the system. So we believe in that bronze alloy.
So something to add to what Troy was talking about with the bronze alloy is not only do we make the bronze fitting, we make the alloy that the fitting is made from, that's made in our foundries. So, and then something else that he mentioned is that pitch on those threads and the perfection of those threads. for those of you out there that are doing hydronics, especially if you're using glycol solutions, or if you're doing solar thermal, you know, glycol, low surface tension, slippery stuff, it wants to get out. I can tell you that these threads are cut so well that if you're in the habit of using cord or using hemp to seal your fittings, you're gonna find that a lot of times you gotta use less hemp or cord than you would normally use because it's such a tight connection depending on the thread you're mating to. And also a really good product for making sure you get a really good seal is Loctite 55 thread compound. It's the white in the tube, like a toothpaste size tube, but the stuff is like $60 or $70. It's very expensive, but using a tiny little bit, it's a real high quality, high grade Teflon sealant. So if you really got to make sure air's not getting in, fluid's not getting out, and you're using glycols and things like that that have that low surface tension, then that's what I would recommend, because to Troy's point, they're really precise threads, especially if you're mating Viega threads to Viega threads for any reason. So just be aware of that.
Absolutely. Thank you, Bo. One other thing that we always get a question about, I see everything popping up. It's so cool. I'm like watching all the hearts and things coming in. So it's kind of distracting with my ADD. But so copper tubing prep is a major question that comes in training, in person, you know, on the telephone from tech support. You know, we hear like, you know, I heard I have to use sandcloth. I heard I don't have to. How do I prep your tubing before I put it in? What's the right way to do it? So if you're looking at brand new copper tubing, so I got some Type L right here, brand new copper tubing, never been used in a system, you know, kind of left over, kicking around in my garage, but it's still new. There's no marks on it. I didn't drag this in the dirt, you know, across the pipe yard or anything like that. So it's nice and shiny. I don't have to sandcloth this. I don't have to clean this up. All we ask is you ream and deburr. Ream and deburr is just good industry practice because, you know, we say, you know, in our manual, cut with a tubing cutter, right? So cut with a tubing cutter, but sometimes I like cutting with my mini bandsaw. Well, that mini bandsaw, fine tooth saw, leaves burrs on the outside of your copper tubing. So just go ahead and make sure that you deburr. So, right, I'm going to deburr that outside, and I'm going to flip this around. I'm going to ream the inside. That's just good industry practice, so ream and deburr. I don't have to sandcloth this. It's nice and shiny, brand new. But service work. I'm doing a repipe. I'm running into something that, you know, is all dirty and gross like this. And I got to tie into this, right? Look at all that. It's all corrosion, flux, grease, dust, dirt, everything possibly on there. All right, so now this is where I'm going to go ahead and grab my Scotch-Brite, which I left on my toolbox over here, Bo. I like Scotch-Brite, so I want to grab that. So Scotch-Brite, because not that abrasive, right, on a copper tubing system. So I just use a piece of Scotch-Brite. Just really clean that up real quick. And then wipe it with a clean hand or a glove. And then I'm bringing it back to its original copper sheen, right? So and I'm doing that because it's service work. Now, in the manual, we don't say or mention anything about using Scotch-Brite or having to clean the fittings. The only mention in the manual, it says, you know, make sure it's a clean surface. That's really all it says. So what does that mean? You know, well, clean surface means, you know, hey, it's a brand new piece of copper that's shiny and good. But if it's old like this, dirty, it's got all this debris on there, I'm going to take a piece of Scotch-Brite, clean that up, and you'll be good to go.
Hey, Troy.
Yeah, go ahead.
I was going to ask you, what about this? I'm going to see if I can.
Can I see? Oh, there
right
it goes.
there. Maybe you can kind of see it.
Yep.
See
right
it?
on the
You
top.
kind of see it? So maybe you can see it from the light here if I shade it. I'm trying. I'm doing a horrible job, but you can see that tubing has been stamped.
Yep.
Right? What do we do about that?
That's a good example. That is a good example. I'm glad you had that because a lot of the copper tubing
why the hell is that there? You know, I got it right here. I mean, it's here. So
there you go.
Why do they got to punch holes in my tubing?
So that etching and it, you know, for me, I thought it was new. You know, you and I have had this conversation. I was like, is this new? Like, I've never ran into this because, you know, the brand new copper tubing I have, you know, it's just a print line. It's just a print line that says, you know, what it is, NFS 61, 3/4 inch, you know, all that stuff. The print line that per the standard is supposed to be on there. So per the standard for how tubing's made, which is ASTM B88, per that standard, it's actually written in that standard what you're supposed to do as a tubing manufacturer for marking and printing that tubing. and especially for NSF61 listings. And there's an interval marker, right? So if you saw on Bo's piece of tubing there, he had a print line, then every interval probably down that print line, there was a stamp or an etch. And I wasn't sure what that etch said. Did that say NSF61 on there, or was it ASTM B88, Bo? What did that?
You're asking for 50-year-old eyes to do something for you here, Troy. It says type LWCP made in USA. So it does not call out NSF61. It's on other pieces that I have. It's been on the print line. I could not find it where it was incised with other than the type on any of the tube that I have. That's here, and we've got tons of it here, and that's just what I found.
So again, that engraving, that etching, that incision mark on that tubing, that is actually a requirement. That is a manufacturer's allowed to use. And again, it's right in that ASTM standard. So with that etch, with that stamp, make sure that's, again, even though it's clean, brand new, you saw how shiny brand new copper was, but because that section right there has that stamp, has that etch, you're going to want to sand that down too. Just smooth. You don't have to grind it down, get it completely out. I've noticed with sand cloth or 80 grit sandpaper or flapper wheel sandpaper, it'll actually smooth it out enough where that sealing element will seal around that edge. So just keep that in mind. If you see a stamp, you see an etch, you see a sticker. I don't have a sticker on a piece of pipe, but I don't know, you go to Home Depot, you go to Menards, you go somewhere like that, Lowe's, there's stickers all over the damn tubing everywhere. You don't want to press on that sticker either, so make sure you get that sticker off of there. So don't press on stickers. Don't press on, don't press onto, yeah, there you go. See, perfect. Smooth it right out.
That was with
Nice.
Blue Monster. There it is. It's coming around.
No, I
Yep.
can
So
smooth it
barely
right out.
even
That's
tell.
perfect.
It's right there. Barely even see it. That
There you
standard.
go. I'm glad you had
language.
that.
Well, the language in the standard predates ProPress. ProPress is the first. We were here first. We started this party, 99, right? Tonight we're going to press
Yeah.
like it's 1999. Someone else threw that out. I'm going to find it and give them a shout out right now.
You're going to find and give it a shot, yeah.
Yeah, yeah, so, it's been around. So this is not a new thing. So just be aware. Sorry, Troy, I interrupted you before you were about to point something else out.
Oh no, you're good, man. This is all fun. I'm getting distracted too by the letters and the words coming up. That's just fun. So whatever's on your mind, ramble it out. If you see any questions in here, I saw a question come up about refrigeration fittings. Are we coming out with them, Bo? And that's always been kind of like the I don't want to talk about it type thing, because it's the type of thing where I hate giving launch dates. When Viega is coming out with a new fitting system, when they are innovating a new fitting system, they're always the ones to innovate something new, to come up with a new technology. Now, yeah, refrigeration fittings from, Parker and other companies have came to the market first before Viega has, to speak, but Viega takes several years. And what they do is it takes them several years, and they sit down, they innovate, and they develop a fitting. So when it's launched, it's a good fitting system. It's going to be a reliable fitting system. It's going to be solid. So I hate giving dates, because especially with this whole COVID pandemic stuff that's delaying manufacturing, I don't know where that project sits anymore, honestly. We were ramping up to talk about it and train on it and develop courses on it. And then it kind of, got kicked to the side because, somebody wasn't happy with the design. It wasn't up to our standard, because we have a high standard, right, of quality. And they went back to the drawing board, and then we started developing MegaPress fittings. I mean, we just launched MegaPress G XL up to 4-inch, so large bore fittings, 2.5, 3, and 4-inch for gas. And we're going to be launching ball valves for MegaPress. We've already launched our 3-piece from 1/2 to 2-inch. We're going to be launching gas valves for MegaPress, and we've been launching up to 4-inch MegaPress valves. So we got a lot of stuff coming out. We're going to be launching our own branded tools, Viega branded tools. So look out for those. Powered by Rigid, still a strong partnership with Rigid. It's just we're going to be coming out with our own, our branded jaws and tool kits and pack out gears and just different things that are coming out this year. So a lot of stuff coming down the pipe. And refrigeration and med gas, it's there on the docket. I just don't know where in that list of launch that it will be available. So stay tuned. Maybe we'll be able to do a Tech Talk Live on it, when they come out, and you'll be able to see all the new innovations. So we'll keep doing that. Another thing I want to talk about, because we could keep rambling all day on this stuff, but there's a few points we want to make in this episode. And I get another question all the time, is how close can I press near an existing solder joint, right? So So I made one up right here. So if I got to go in and I got to exist now, this is one thing. Look at these boogers. Now this isn't my solder job, so don't pick on me. It's a repipe. It's a repipe that I ripped out. So I kept this fitting just because I thought it was cool. Don't press on this either, right? See those boogers, right? Don't press on that. That has to be cleaned up. But if I need to press near an existing solder joint, I can actually be 1/4 of an inch away on most sizes. So half, 3/4, 1, I believe even 1.25 inches. But check our manual because for the most part, it's about 1/4 of an inch away, just like you see here. So I can press 1/4 of an inch away from an existing solder joint. That's how close I can get near an existing solder joint. So if I'm doing service work, retrofits, things like that. But the other thing that comes up is, well, what about the opposite? What about I go into a scenario where maybe it's a hybrid system? Maybe I'm doing ProPress for my mains, my risers, my drops, but then I got to sweat on some adapters or tie into equipment, something like that. How close can I solder near an existing pressed fitting? So, how close can I get? Now, in our manual, we say if you're going to be soldering near an existing ProPress joint, you're going to be 3 times the OD of the, fitting or tubing that you're using away. So 3 times the OD. So OD of 3/4 inch is, what, 7/8 of an inch times 3, that's 2 5/8, right? So that's how far away I got to be before I sweat this up. So I did that today just so I could see, and yeah, obviously, if now this again is for the average installer. So our stuff is, to make sure that if I'm dealing with 100 contractors, they're all going to do the right thing and stay consistent and have a consistent, reliable seal every single time. So clearly, if I'm skilled, and I have different torch tips, I got some sort of heat sink paste, right? You guys see, solder weld, heat block on here all the time. So, I mean, if you're doing something to mitigate that heat, sure, you could get closer, but a good, average, install with no protection. I didn't protect this fitting at all that's been pressed. I just went ahead and I did the 3 times the OD, which is, 7/8 of an inch on 3/4 inch tubing. So times 3. And that's how far I am away here before I sweat this joint on here. So those are all in our manual. If you need to braze near an existing ProPress fitting, you got to be 9 pipe diameters away because brazing is a hotter heat. It's way hotter than soldering. So it's 9 times, soldering's 3 times. And then again, if I need to press near an existing solder joint, it's 1/4 of an inch. So that's all you have to pay attention there when it comes to, prep and pressing and everything. So I'm trying to think if I have anything else here, Bo. We talked about stamp tubing, What about pressing over an existing, solder joint, right? Maybe you have to unsweat a fitting because you're in a tight space. I can't just cut an assembly out. There we go. What if I have to press over something that I unsweat and pulled the fitting off?
This person that sweat this one already unsweated it for us in that they never sweat it in the first place. So this is an actual fitting that was pulled out. They cut it with a bandsaw, so it's not square. And you can see where it was capped all the way around. And I think Gunny gave us this piece just as a sample. You see this all the time. Back to Troy's point, you could solder over this. You could press over this. You want to heat it up, wipe all the solder off. Troy will get into that in a second about cleaning it up. But something else Troy mentioned is when you're pressing near an existing solder joint, actually recall that for 2 inch, it's actually 3/4 of an inch that you want to be away because of the mechanical deformation, whereas a XL type fitting or a large type fitting with a grip ring, 2.5 through 4, you can be 5/8 away. And that's just for clearance of the ring, right? So 3/4 is the largest distance in the manual. If you got to, be absolutely sure that's where you want to be. But to Troy's point is, even if I was 3/4 away, an inch away from this fitting and I pressed on it, chances are I would have cracked this solder joint. Now, it wasn't, you can't even call this a solder joint. That's not even fair to call that a solder joint because that's the only full penetration we got was on roughly 1/4 of the joint. Okay, but it probably would have cracked it. So just remember when you go in on old work, you don't know who touched it before you. So you might have holidays or flux pockets. My dad used to call them holidays, but then he used to say that I was half a bubble off a plum, and I used to say I like peaches. So I don't know what he ever meant. But anyway, yeah. So just remember, old work, you never know what you're running into. And I know Troy can tell you that from the field as well.
Yeah, absolutely. I mean, again, when I pressed, this close to this fitting, I'm not sure if the, installer before me did a good job. I inspected the joint. I'm looking at it. It seems like it's capped off pretty good. So I got within a quarter of an inch and it, like the manual says, and I didn't crack it. But you're absolutely right. What if that joint wasn't properly done, half done, just barely, any solder in there. Maybe the top was capped, but no full penetration. Stuff like that can happen, So, I will tell you, I have an instance where somebody with a solder joint, right? So, we always joke about insertion depth here. Hey, make sure it's important with insertion depth. Insertion depth is equally important in solder joint. I had somebody sweat a joint. I just barely put that in. I had somebody sweat a joint like that once, and I'm working in an industrial plant and I'm working on a ladder overhead, and I'm doing some joints and some pipe runs, and I step down. I wear these big Chippewa or Justin Lager boots, just what I like to wear. And I come off that ladder and I accidentally stepped on the piping that was behind me because they had piping running on the floor. They had guards blocking it, so nobody hit it with fork trucks or equipment or things like that. But it was some processed water, some glycol runs, things like that. And because somebody just barely put that sweat joint together, I cracked that joint, and it was the glycol line, glycol everywhere. So, insertion depth's important in all joining methods. I'm dying. The biggest plumber, man. I'm dying with his comments right now, man.
Yeah,
I can't stop.
he's in love, man. He's got a
Oh
man crush
man,
on you, buddy.
I'm
Telling
dying.
you.
I'm dying. Oh man, this is great. I'm loving this. This is way better than Zoom, man. This is
Way
way
better.
better. I'm
Way
loving
better.
this. This is great. Thank you everybody for joining in today because this is fun. This is great because when Bo and I are in person doing these trainings, it's the camaraderie, it's the joking, the laughing, and right now I'm working in my garage and I stare at myself, so it's not as fun. This is bringing back the fun. So thank you.
So Anewa Wagui asked us, and thanks, shout out to them. They asked if we can press on soft copper, and Erica actually answered, but maybe you want to talk about that because we talked about the standard earlier, B88, and
Mm-hmm.
B88 actually calls out something on that as well. Maybe you want to elaborate.
Yeah, absolutely. So in our manual, we say you can press on half all the way up to inch and a quarter soft rolled copper. And that is just because, we've always explained it's because, the larger the sizes, the more oblong it gets. You can't necessarily get that hexagonal deformation. But as Bo and I dived into the standard, why is it the roundness not the same? Why is it inconsistent? It's actually in the standard that there is no consistency to the roundness of tubing when it's soft rolled by the manufacturer. So wherever I'm getting my copper tubing from, it could be from all over, it's all different. It could be all different, not in the same specification, not within the same tolerances. So we know, and we've tested half to inch and a quarter, and we know you can get a consistent, reliable seal on half to inch and a quarter soft rolled. Anything above that, it's been so inconsistent. So we do not guarantee it. So I've seen installers do it on 2-inch soft roll on main and a hold. I've also seen it blow off. So again, we can guarantee it on half to inch and a quarter. After that, I can't guarantee the workmanship or the manufacturer's roundness factor in that tubing to get that hexagonal deformation. So half inch and a quarter, you're good. Anything over that, I can't prove the consistency and have that reliability like everything else. So just keep that in mind. It's a gamble if you try it over inch and a quarter, but you can definitely do it on half to inch and a quarter. And that's type L and K on soft roll, and then on hard drawn sticks, it's M, L, and K. Anything thinner than M, we don't press onto. That's why we don't do drainage copper, so we don't do DWV copper, because DWV copper is thinner. The wall thickness is thinner than type M tubing, and we don't press on anything thinner than M. So that's why we don't do DWV. Plus, we don't have drainage pattern fittings anyhow, right? We don't have TYs and things like that in press. So just keep that in mind.
Awesome, Troy. So, man, the questions are just flying in.
I know, it's great.
Habibine91 asked about the hexagonal deformation causing turbulence in the pipe, like not reaming. And, that's a really good point, because if we make a cut on tubing, and I think I've reamed this tube end, but, if we make a cut, we get a really bad especially on type L, type M.
I haven't
There you
read
go,
this.
Troy. Yeah. So,
Yeah.
the code says we have to ream that to the full ID, right? And you don't
Yeah.
want that turbulent flow, because what happens is when we've got fluid flowing through that tube at high velocity, it hits that essentially a ramp. It's like a ramp, and then that turbulence comes around and it slams the backside of the fitting, and what you get is erosion corrosion, which you will see in piping systems. You cut out a system, you look at the tubing, especially on the opposite end of flow, on the outlet side of the fitting, you'll see that the copper is just pretty much washed away like the Grand Canyon. And so that's a common problem. And so common question we get from engineers, does that hexagonal deformation cause turbulence? Is that going to cause issues with the tubing? And what we like to explain that is no, it's not going to happen as long as you ream your tubing, which you should do anyway, whether you're soldering or pressing, it's irrelevant. Whether you're threading pipe, you need to ream back to full ID. But the thing to understand is if you look at the pattern of a Viega press fittings or mandrel drawn, okay, they have a very soft inner bend to the fitting and a nice smooth long heel, okay? And this is actually a short turn. We used to have longer turn fittings, but I think it was 2016 when we stopped, and we now have a shorter turn pattern fittings all the way up through our 2-inch sizes. And these fittings are mandrel bent, so they're very consistent across the curvature of the fitting. So the fitting that this actually replaces, the solder fitting, actually has a lower pressure drop across the length of this fitting, an equivalent length. So even if there is a little bit of change to the ID of that pipe with that slight deformation, and it is really small. I don't know if you got a sample of it there, but it's a lot less than it looks like when you look down the tube. Yeah, it's very, very small.
Look at that.
Yep.
See those dimples right there? I mean, to your point, I mean, if a river was running through this, I mean, it's just the water's going over those dimples softly, right? It's not that that ream part, that lip, that's a sharp lip. So it's like a gate. The water hits it hard and turbulence, right, happens, which causes erosion, corrosion, and jackhammers the other side of the tubing and causes pinhole leaks. The water's going to flow over these nice and even because it's a slight deformation on the inside. Look at those dimples, not sharp edges. They're smooth dimples into Beau's point because we have that longer radius, that nice flow fitting. You're not causing that turbulent flow inside that fitting, even if it gets a little ripple from that deformation. So you're not, it doesn't cause erosion, corrosion, or turbulent flow. So very good question, because engineers hammer us that all the time about how to design, how to do everything. So, that's actually a very good question.
You bet. So I think we're near the top of the hour here, Troy. Did you have anything else you wanted to add today?
159 already.
I just want
to,
Time flies when you're having fun.
I just want to thank everybody for being here in our debut episode on Instagram of Tech Talk Live. We're going to be doing this once a month, just so we're going to be putting out our teaser videos. I'm going to be putting out videos of In the Know with Trainer Troy. Beau's going to be doing his teaser videos to keep you in the loop throughout the month. But we're going to do the show once a month so we have time to create stuff, to get comments and questions from the audience. So, our next episode is going to be August 26th at 6 p.m. Central. We're going to be bouncing back and forth every other month from 12 p.m. Central and 6 p.m. Central, because we want to, gather guys that maybe are on lunch break today or at home or anything like that. And then maybe later on the next month, you get home from work, you crack a beer, you sit down, relax, and you can join us on Tech Talk Live. So we're going to be bouncing back and forth between those time slots once a month. So tune in next time, August 26th for this. And Beau, how can they get a hold of us if they have ideas?
That's awesome. Thanks for everybody that attended today. It was really cool. This was a lot of fun. This has been the most fun, actually. It's just kind of really fun seeing all the comments, and it's just really awesome. So really good to